Okay, assalamu alaikum everyone. I hope you're all well. Walaikum assalam wa rahmatullah. I will be doing P3 streams, P3, P1, S1, all of them. I will be doing them inshallah. As we get close to the exams, I will be doing those streams inshallah. Okay. Acha. So in this session, we are going to do this Ad Math paper. This is IGCSE O-level Ad Maths. We will be doing the paper from November 2025. It's a non-calculator paper. ये हम आज कर रहे हैं सेशन के अंदर इंशाल्लाह. It's a free past paper session that I'm doing over the next 10 or so days. जब तक आपके दोनों papers हो जाते हैं AdMaths के. The plan is that I attempt somewhere around 10 papers in total. और उसके साथ you'll get access to more recordings as well. Okay, so these are the details of the past paper session. It's a free session. If you want to join, you can have a look at the description. And in fact, let me just add it to the description. I haven't done that yet. Just give me a second. I'll add it to the description. I'm going to add the link to the description using which you can join the session. As in, I'll be posting details about the timings there whenever we're going to start, because every single day the time is going to be different. So you can access those details in that group. और उसके अलावा I'll be trying to answer your questions in the group as well. You guys can make it interactive and help each other out as well. But I'll be responding to your questions in that group as well, inshallah. ठीक है, we're just going to start in a minute. I'm just setting a couple of things up and then we begin, inshallah. Just give me a second. So I'll add it to the description there. Also upload the thumbnail. Okay, so now it is in the description, the link to join the session. If you're interested, you can fill out that form and you'll be added to the group. It'll make it quicker if you just send a message to the number that is given there as well in the form. After you've submitted, take a screenshot of the submission page and submit that. Send that screenshot to the WhatsApp number that is shared there. Okay. Shall let's begin then. Okay, so please make sure that you are attempting the papers before we do them in classes. So I'll be posting in the WhatsApp group which paper we're doing on each day. It'll be almost every day from here onwards, inshallah. I'll be posting what paper we're doing on a particular day. Make sure that you have attempted that paper already before we do it in a particular class, because otherwise just watching me do everything, that is not going to be as helpful. Okay, and make these classes interactive. If there's anything that you don't understand at any point, you can ask questions in the live class. You can ask in the chat here. Offline, you can send your questions in the WhatsApp group as well. So make sure that you are attending the paper yourself first of all. That is important. Chale, let's begin with this then. Let's start with this. This is November 2025. November 25, paper 1, 2. Let's begin with this. Further maths का कुछ करना है. Unfortunately, I haven't started teaching that yet, but we've been planning something, Sir Zain and me. Hopefully, we might do something this year. We plan every year कि हम summer में कुछ करेंगे शुरू, but it just keeps getting delayed. Let's hope we can actually sit down and do something this year, inshallah. So you might see some content coming over the next year, inshallah. ठीक है, चलें. Let's start with this. November 25, paper 1, 2. Let's start with this. You have this formula sheet given, right? You have this formula sheet given. जिसमें आपको जो important formulas आपको चाहिए होते हैं, they are given there. Let's start with the first question. Remember, it's non-calculator. Remember, it's non-calculator, so you're not supposed to use a calculator. At home, when you're practicing, please do not look at the marking scheme after every question that you attempt. Attempt the whole paper first and then look at the marking scheme at the end of the paper. Do not open the marking scheme in the middle. That's not going to be helpful. Okay, chale. Achha. Now they're saying on the axes, sketch the graph of this function stating the intercepts with the axes. Okay, now it's a cubic function. You've got three x terms multiplying. It's a cubic function. What are the possible shapes of cubic functions? You can have something like this. You can have something like this. Sometimes if you don't have two turning points, it's like this or this as well, right? So it's going to be one of those shapes. Now the shapes on top here are what we get when the coefficient of x cube is positive. Okay, these are the shapes that we get in that case. When the coefficient of x cube is negative, we get these shapes where the graph is going in the downward direction. Okay, now which one of these cases is this going to be? You see, this is minus x, minus x, x, and 2x. So the coefficient of x cube is going to be minus 2x cube, right? The coefficient of x cube is going to be negative 2. So it is going to be one of these shapes at the bottom. Okay, keep that in mind. Now, what are the intercepts? What are the intercepts? If you put y equal to 0, what are the values of x that you get? You get x equals 1 from the first factor, you get x equals 5 from the second factor, and x equals 5 over 2 from the third factor. These are going to be the x-intercepts of the graph. And then what about the y-intercept? Ji beta, hello. I'm good, alhamdulillah. I hope you're here to do add maths and not just to send random messages. Okay. What about the x-intercept? How do you find the we have found the x-intercept. What about the y-intercept? We put x equal to 0, and that will just give us the constants, right? So that's 1 into negative 5 into negative 5, and that's 25. So the y-intercept is going to be at 25. Okay, the y-intercept is going to be at 25. Yes, exactly. So the shape is determined based on the coefficient of the x cube term. So in this case, if the function is like this, ax cubed plus bx squared plus cx plus d, this a determines it, right? So it's going to be upward sloping for most of the graph if a is positive, and downward sloping for most of the graph if it's going in the downward direction. Okay, Acha. Now y equals 25. Let's put that number there. What about the intercepts? X equals 1, that is one intercept. Let's mark that here maybe. 5 over 2 is 2.5, right? So let's mark it here, 2 and 2.5. It might be somewhere around here. And then 5, 3, 4, 5. So roughly it's going to be here. Okay. Now the graph is supposed to be like this, right? So you have to make that shape. How do you do that? You will do something like this. It'll go downwards. The graph is going to cut the x-axis at this point. Then it's going to come up, and then it's going to go down again. This is how you would sketch the graph. Okay, that's the shape that you would end up getting from this. Is that okay? Acha. Let's get rid of this. How do I do that? Yeah. Okay, all good. Acha, now the chart will be cleaner. Chale, let's move on to the next one now. Part B. Hence solve this inequality. Hence solve this inequality. How do you solve this inequality? You have less than or equal to 0 sign. It's the same function as before. It's the same function that you have plotted in the previous part. If they asked you to solve this equation when this is equal to 0, if it is equal to 0, you would say the solutions are these: x equals 1, x equals 5, x equals 5 over 2. But this is an inequality sign. Less than 0 means look at the parts of the graph that are below the x-axis. What are the parts that are below the x-axis? You have this part and you have this part. Now, what values of x correspond to these parts on the graph? From 1 to 5 over 2, and then from 5 onwards, right? So this region and this region, these are the two regions that satisfy that inequality. So we can write them directly like this. We can say x is between 1 and 5 over 2, or x is greater than or equal to 5. Now you put equal to sign with that as well because the inequality has an equal to sign. So it's going to be like this. Is that okay? The value for k, what do you mean by k? Are you saying the value for a, the coefficient of x cube? Coefficient of x cube? That value is negative 2 in this case. That's negative 2. So you can say because of that, the minimum point is going to be first and then the maximum point and then like this. So if you call that min-max graph, yes, that's right. Okay. Acha. Let's move on. That's the solution of the inequality. Okay, if you have any questions, do make sure to post them there. Let's move on to the next one now. The polynomial p is such that p. Okay, acha. Okay, the polynomial p is such that p of x is equal to this, where a and b are integers. It's given that x plus 2 is a factor of p of x. When p of x is divided by x plus 1, there's a remainder of 6. Find the values of a and b. That's a standard question on polynomials, right? We're given two pieces of information. One is that when this polynomial is divided by x plus 2, it's a factor. Factor means the remainder is going to be 0 in this case. The remainder is going to be 0 in this case. Okay. And the second thing is when p of x is divided by x plus 1, in this case, the remainder is 6. So you'll just make two simultaneous equations from this using remainder theorem and then solve those simultaneous equations to figure out the values of a and b. That's a standard question in polynomials, keeps getting repeated again and again. So what value of x do we input? We put x plus 2 equal to 0. What value of x do we get from that? X equals negative 2, right? Input that in that polynomial. So the remainder from this division is going to be p of negative 2. When we input x equal to negative 2 in that, what does that equal? 2 into minus 2 whole raised to power 3 plus a into minus 2 whole squared plus 13 into minus 2 plus b. On the other side, you will write the remainder that we know, that is 0. So this is one equation that we've got. Now you're not allowed to use a calculator, so be careful in your calculations. Minus 2 cube. When you take cube of a number, the sign remains the same. It's going to remain negative. 2 cube is 8, so 2 into negative 8, what does that become? That becomes minus 16. Plus a into 4, that is 4 times a, plus 13 into minus 2, that is negative 26, plus b, that equals 0. Let's simplify this. That gives us 4a plus b. If I add these two up, that gives me minus 42. I can take it to the other side and that becomes 4a plus b equals 42. That is one equation that we're getting. Okay? Acha. Now, what about the other one? From the other one, how can we find the remainder? Put x plus 1 equal to 0. What value of x do we get from that? What value of x do we get from this? Minus 1. Let's see what this turns out to be. 2 into minus 1 whole cube plus a into minus 1 whole squared plus 13 into minus 1 plus b. Okay. Now, what should this equal? From this division, they're saying the remainder should be 6. So we equate it to 6. Simplify this and see what that gives us. What are you saying, Purdistan? I'm not sure what you mean by that. Okay, that was minus 26, sir. Yeah, minus 26. Okay. Achha. 6 equals minus 2 plus a minus 1 whole squared is a minus 13 plus b. Okay. Now that's what this simplifies to. What do we get from this? A plus b, that is equal to 6 plus 15 from the other side, and that will become 21. These are two equations that we've got. We can solve them simultaneously. You can use any method that you want. Elimination, substitution, whichever you prefer, and that's okay. If I use substitution, I get b equals, although in this case, elimination will be very quick, right? Because this is plus b, this is plus b. You can just subtract the two equations, and that will give you the result. Okay, b equals 42 minus 4a. Okay. What about the other one? Let's make b the subject from this. B equals 21 minus a. Achha, let's equate both of them. This gives us 42 minus 4a, that equals 21 minus a. And we get 3a equal to 21 from this, and the value of a turns out to be 7. This is one value that we were looking for. A equals 7 from this, right? Now, put this back in any one of those two equations, and that will give you the corresponding value for b. If I put that in this equation, that will give me b equal to 21 minus 7, and that is 14. The value of b turns out to be 14. That's the final result that we get. Okay, just be careful that you're not making any careless mistakes, and that should be fine. Okay, not that complicated. That was question number 2, part A. Now they're saying, show that this equation has only one real root. Okay, now what's that equation? P of x is equal to 0. That's a cubic function, right? That's a cubic function. P of x equal to 0. P of x equals 0. How do we solve cubic equations? We need one factor for them, right? Do we already have a factor given? Yes, we have one factor given. X plus 2 is a factor. How do you find the other factor? You can do long division. You can use synthetic division. You can use comparing coefficients method, any method that you're comfortable with, that will work. Now, let's do long division because that's something that everybody knows. So I'll just do that. 2x cubed plus ax squared. 2x cubed plus ax squared. That's the polynomial, right? Plus 13x plus b. We already know the values of a and b now, right? The values of a and b are 2x cubed. Value of a is 7, so that's 7x squared. Value of b is 14, so that's 13x plus 14. That's the polynomial. Now we are given one factor, which is x plus 2. X plus 2 is a factor. Now since x plus 2 is a factor, we can do division, right? And find the other factor from this. Let's do long division. This is the polynomial. 2x cubed plus 7x squared. If you know synthetic division, that will be much quicker than this. But since everybody does not learn that, I'm doing it using this method, x plus 2. Okay, what do we multiply x by to get 2x cubed? We multiply x by 2x squared. Now 2x squared into this whole thing, that will give me 2x cubed plus 4x squared. ठीक है. अब क्या करें? We subtract what we had in the previous step from this. This gets cancelled. We change the sign side. 7x squared minus 4x squared, that gives us 3x squared plus 13x plus 14. What do we multiply x by to get 3x squared? We multiply it by 3x, and that's what we write here. 3x into this whole thing, that is going to give us 3x squared plus 6x. Change the signs again, this becomes minus, this gets cancelled. 13x minus 6x, what is that? That is 7x plus 14. Again, what do we multiply x by to get 7x? 7. So we have 7 here. 7 into that whole thing, that gives us 7x plus 14. Change the signs. This becomes minus, minus, this gets cancelled. And we're left with 0 at the end. That's the remainder. And that confirms that our working is correct because x plus 2 was supposed to be a factor, right? And it's turning out to be 0, the remainder. That confirms that our working is correct. And now this is the other factor. This is the other factor. Okay? Now, all you have to do is equate this other factor to 0 and see if you get any other solutions from this. So the polynomial now becomes x plus 2 into 2x squared plus 3x plus 7 equal to 0. The first factor gives us x plus 2 equal to 0 and x equals negative 2. That's the only solution that we've got. That's one solution that we've got. Now, from the other equation, 2x squared plus 3x plus 7 equal to 0. Now we need to show that it has only one real root. It has only one real root. If it has only one real root, that means we should not be able to solve this quadratic equation. It should not be possible to solve this quadratic equation, right? You can try solving it and show that you don't get anything from this, or a quicker, more efficient method would be you find discriminant. If the discriminant is less than 0, that proves that you get no further solutions from this. Let's find discriminant from this and see what that turns out to be. B squared minus 4, you see that will be 3 squared minus 4 into 2 into 7, and that will give you some negative number. It's not even necessary to calculate that number. You can just write negative there as well, but it's still a safer idea to just do that calculation. 3 squared is 9 minus 8 times 7. What's that? 56. 9 minus 56, that will become negative 47. Now, since it's a negative number, it's less than 0, you say there are no further solutions. There are no other solutions. And if there are no other solutions, we have only one real root, and that's this one. Okay. Was it 4 into 14? Actually, let me just check that. 4 into 2 into 7, that's 8 times. Why are you saying that? 9 minus b square minus 4 AC. ठीक है, अच्छा. You want me to do it using synthetic division as well? Okay, I'll just do that quickly. If you have done synthetic division already, then that might help. Otherwise, don't get yourself confused at this point. It's not a good idea to learn something entirely new at this point. You can do everything using long division and it'll work. But if you have done synthetic division, this is an alternative method to do it. You could say the coefficients of that polynomial, you can write them down here, 2, 7, 13, and 14. 2, 7, 13, 14. Now, what are we dividing it by? We are dividing it by x plus 2. So we write negative 2 here. 2 comes down as it is. The first coefficient, that will come down as it is. We multiply negative 2 with 2, and that gives me negative 4. Add these two numbers, that's 3. Multiply negative 2 by 3, that's negative 6. Add these two numbers, that gives me 7. Multiply these two numbers, minus 2 into 7, that's negative 14. And that gives me 0. This is the remainder, that is 0. And these three terms give us the other factor, that's the quotient, and that is 2x squared plus 3x plus 7. That's exactly what we got there as well, 2x squared plus 3x plus 7. Right? That's an alternative to long division when the divisor is linear. And you see that's much more efficient, much quicker. If you already know this, then you could do it this way. But if you haven't done this before, just know that everything can be done using long division as well, and it'll work every time. Maybe you can learn it later in A levels if you want to make things a bit more efficient. ठीक है, चले. Let's move on to the next one now. let's look at the next one. Question number 3. Question number 3 from this paper. Now we have an AP-GP question. Let's try this. This is November 25, paper 1 and 2. We were doing question number 2 earlier. Let's move on to question number 3 now. Okay, chale. The sum of the first two terms of a GP is 9. The sum to infinity of this GP is 25. Find the possible values of the common ratio of this geometric progression. Okay, how do we think about this? We have a geometric progression. We are given that the sum of the first two terms, we can say S2, that is equal to 9. One way to write this could also be A plus, what's the second term? The second term is A times R. A plus AR, that is equal to 9, right? That's what we're given. The first term is A, the second term, A times R. This sum is 9. Sum to infinity is 25. What's the sum to infinity formula? A over 1 minus R, right? That is equal to 25. So we've got these two equations. We will just solve them simultaneously. Find the value of common ratio, that means R from that. Okay. Now, how do we find ratio? We can eliminate A from this equation, right? Let's eliminate it from the second equation. If I do that, I can say A equals 25 minus 25R. If I multiply this on the other side, let's put that in the first equation. Let's put that there in the first equation. Now, if we do that, in the first equation, I think it will be a good idea to first... I'm just thinking it might become slightly more efficient if I just leave it like this, 25 into 1 minus R. In the other equation, I could write this as A into 1 plus R equals 9. 1 minus R into 1 plus R, that could make things more efficient, right? Okay, so let me explain my thinking behind it. What I've done is, I'm not multiplying 25 with 1 minus R. The reason for that is I saw that we had 1 plus R here, right? We had 1 plus R here. So it might be a good idea to multiply 1 minus R and 1 plus R, and that will become 1 minus R squared, right? That will make things more efficient. Achha. Now, let's input that here, and that will become 25 into 1 minus R into 1 plus R, that is equal to 9. Now 1 minus R into 1 plus R, that's A minus B into A plus B, that becomes A squared minus B squared, right? That's 1 minus R squared. 25 goes to the other side, and that's 9 over 25. Now, let's make R squared the subject. If I take R squared to the other side, 9 over 25 comes here. 1 minus 9 over 25. Remember, calculator is not allowed, so you need to be able to do it. Without a calculator. 25, 1, 1, does that even exist? Because I haven't seen variance 1 of admins. Really? Acha. 1 minus 9 over 25 equals R squared. Okay. Now 25 minus 9, what does that become? 16 over 25. That is equal to R squared. Take square root on both sides. What's the square root of 16? 4. Square root of 25, that is 5. Do not forget plus minus. We get R equals plus minus 4 over 5. That's the result that we get from this. Okay, these are two possible values. The question says possible values. That means multiple values. That's the result that we get. Oh, okay. 0606. Okay, all right. We'll have a look at that as well. We'll have a look at that as well for IGCSE and Chara. We'll do that as well. We're going to focus on November papers and the March paper. November papers and March paper for the non-calculator version, and then the last day, the day before exam, on Sunday in Chara, I'll do an open session in which you can bring any questions that you might have. In particular, I would want to solve all the difficult questions from June 25 and March 25 on Sunday in Charo. ठीक है? Yeah, that's right. So I actually did not see variant 1 for that. Okay. Chale. Part A. That was part A. Let's look at part B now. It says find the first term of this GP for each possible value of the common ratio. Okay. First term. So we just have to find the value of A now. What's A? We can either use this equation or the other one. What does that give us? A equals 25 into 1 minus R. Let's input that there. A equals 25 into 1 minus R. Let's input those values of R. R equals 4 over 5 or R equals negative 4 over 5. What values of A do we get from this? Again, without calculator, you have to be careful. 1 minus 4 over 5. What does that give us? 1 minus 4 over 5, that will become minus 1 over 5, right? Sorry, plus 1 over 5. 1 over 5 into 25, that will be 5. Okay, if you can do it directly, you can do it. But just make sure that you're not making any careless mistakes. So it's actually a good idea to just write it down. 1 minus 4 over 5, 5 minus 4, that will become 1, right? So 1 over 5, and that gives you 5. Okay, that's the first term. Now, in the other case, we get A equals 25 into 1 minus 4 over 5. What does that become? 1 plus 4 over 5. And now 1 plus 4 over 5, that is going to become 9 over 5. And that leaves us with 9 times 5, which is 45. That's the other possible value of A that we're getting. ठीक है? Okay. Makes sense, right? Any issues with this? Okay. Let's look at question number 4. Let's look at question number 4. We'll talk about the general things at the end, right? I want to finish this early because there's an A-level paper tomorrow as well. So let's focus on the paper. We'll do the general discussions in the next classes, inshallah. Okay? There's an A-level paper 3 tomorrow for international students, not for Pakistan, but I need to spend some time with them as well. Just show that this can be written in this form, where A and B are constants to be found. Now we just have to complete the square. How do we complete the square? There are multiple methods for completing the square. You can use any of them that you are comfortable with. Any method is not required in for completing square questions. Okay, because the marks that they have in the marking scheme, they're just for the final answers. Okay. So whichever method you're comfortable with, you can use that. One fairly efficient way of doing this is we find the turning point, x equals minus b over 2a, or differentiation. If I do x equals minus b over 2a on this, what do I get from that? Minus 5 divided by 2 into 2, and that gives me x equals minus 5 over 4. That's the x coordinate of the turning point. Find the y coordinate of the turning point. That will be 2 into minus 5 over 4 whole squared plus 5 into minus 5 over 4 plus 3. Okay, this is one way of completing the square. Of course, the standard way, all of you, I think, already know. Take 2 common, divide the coefficient of x by 2 after that, square that, add that, and subtract that, and so on. That will also work. This is an alternative. If I do it this way, what do I get from this? 2 into minus 5 squared, that will be 25, 25 over 16, minus 25 over 4 plus 3. Okay, let's do some simplification. 16 and 2, they get cancelled to give us 8 here. Now, if I take LCM, I would have 8 in the denominator. 25, this will be multiplied by 2, right? That's minus 50. This will be multiplied by 8. 3 times 8 is 24. Now, what does that give us? 25 plus 24, that's 49. 49 minus 50, that is minus 1 over 8. That's the y coordinate of the turning point. Once you have the x coordinate of the turning point and the y coordinate of the turning point, you can say this is the value for h, this is the value for k. Just input them in that standard form. What's the standard form? A into x minus h whole square plus k, in which the value for a is the same as this value. So that will be 2 into x minus h. What's the value for h? Negative 5 over 4. So that's x plus 5 over 4 whole squared. Plus k. K is negative 1 over 8. That will be negative 1 over 8. And that's what we were looking for. That's our final result. In the calculator paper, it becomes extremely efficient because you can find the turning point from the calculator directly. And that's allowed. You can do that. In the non-calculator paper, of course, you have to do manual working, and that's okay. But if it comes in the calculator paper, you can actually just use a calculator directly. Okay, I don't have that open right now. But the idea is maybe we'll do that in one of the other classes in calculator paper. You find the turning point from the calculator directly. You can do that, right? Using the equation solving function on the ClassWiz calculator. When you get the x-intercepts, you also get the turning point of the quadratic function at the end. You'll get the values of h and k from the calculator directly, input them here, and that will be your completed square form. Okay, that's pretty efficient in calculator papers. Achha. In the second part, they want you to write down the coordinates of the turning point. We already have found that before. Just write that down. Minus 5 over 4 or minus 1 over 8. If you had to find it from this, how do you do that? Whatever is inside the brackets, put that equal to 0, and that gives you minus 5 over 4. And the number outside, that's minus 1 over 8. These are the coordinates of the turning point. Okay, that's the second part. That's pretty straightforward. That was part B. Now they're saying a function f is such that f of x is equal to this for x greater than or equal to p, where p is a constant. It's given that f inverse of x exists. Now, what are they telling you with that statement? F inverse of x exists. What does that mean? If f inverse of x exists, that means it's a one-to-one function. It's a one-to-one function. Okay, it's a one-to-one function. We need to find the least possible value of p. The least possible value of p. Now, what is p? P is telling you the domain of the function x is greater than or equal to p. It's best to think of this using the graph of the function. It's a quadratic function. The coefficient of x squared is positive. The graph is going to be U-shaped like this, right? It's going to be U-shaped like this. What's the turning point that we have figured out for this? The turning point that we figured out is negative 5 over 4 and negative 1 over 8. And the domain is x greater than or equal to p. So you are looking at the right side of the graph. You're looking at the right side of the graph. You can actually write it down directly. I'll tell you how to do that. But let's understand the logic behind it. There's no way, it's not required that you draw the graph like this. You can write down the answer directly, but I'm just explaining the logic for this. You have this turning point, minus 5 over 4 and minus 1 over 8, right? The domain is x greater than or equal to p. So that means we're looking at the right side of the function. What would be the least possible value of p such that it remains a one-to-one function? So there's p somewhere on the x-axis. Now we don't know where that is. If p was here, for instance, and we were looking at this part of the graph, is that one-to-one? That's not one-to-one. If p was on the right side, we would be looking at this part of the graph. Is that one-to-one? That is one-to-one, but is that the least possible value of p? Not really. We could actually take p a bit to the left side as well. How far to the left can we go? We can keep going. It still remains one-to-one function until we reach the turning point. If we go any further than this point, it will not be one-to-one anymore. So the least possible value of p that you have for this is going to be at the turning point. So what's the x coordinate of the turning point? That's negative 5 over 4. That is what you write down as the answer. The least possible value for p, that is negative 5 over 4. Now that's a standard question. You can write down the answer directly for this in all of such questions. you will just have to write down the x coordinate of the turning point if it's a quadratic function. Okay? ठीक है. So the least possible value of p, that is negative 5 over 4. That's a standard question. This is how you would approach that, right? Because we were looking to the right side of the graph. This will have to be the least possible value of p. Thank you, Ding Dong Ditch Ditch. अपना नाम ही चेंज कर लें इस खुशी में. Write something, use something better so it's easier to call you out in the exam, in the class. जी, ये वन टू वन फंक्शंस, ये फंक्शन वन टू वन जो फंक्शन होते हैं इसका स्टैंडर्ड जो प्रोसेस है, यू नीड टू अंडरस्टैंड दैट व्हेन यू cover the concept of functions. Okay, let's look at this next part now. Using a value of p, sketch the graphs of y equals f of x, y equals f inverse of x. Okay. Label each graph, state the intercepts of each of the graphs with the axes. Now, the graph that you need to sketch is this graph with domain x greater than or equal to p. You will do that as well, inshallah. अब तो आपको टाइम मिल गया आपको बहुत ज़्यादा. Papers delay हो गए. Make sure that you make a lot of effort. I'm assuming you're an A-level student, right? Inshallah, आपके पास बहुत टाइम है, अभी आप कर सकते हैं. You can improve a lot. अच्छा, using a value of p, sketch the graphs of these functions. F of x is equal to 2x squared plus 5x plus 3. The domain of the function using this value of p, that is greater than or equal to negative 5 over 4. That's the domain of the function. Now, let's sketch the graph of f of x first of all. What's the graph of f of x going to be like? It's a U-shaped graph like. So the shape is going to be like this. This is the shape of the graph. ठीक है. This is the shape of the graph. What have we already figured out? We have figured out that for this graph, we are just going to consider the right side, this part of the graph. Now, where is it starting from? X equals negative 5 over 4. So at the turning point, we know x is equal to negative 5 over 4 and y is equal to negative 1 over 8. That is where the graph is going to start from. So let's mark a point there. On the left side somewhere, let's suppose this is negative 1. Remember, whenever you sketch the graph of a function and its inverse on the same diagram, you need to make sure on both axes you're using the same scale. Whatever is 1 unit on one axis, it should be the same distance that you're calling 1 unit on the other axis. Otherwise, your reflection is not going to look very good. Okay? So you need to make sure you have the same scale on both axes. Achha. Let's mark more points here on the x-axis as well. It's a good idea to use your scale to measure. Maybe use 1 centimeter for 1 unit on both axes, and that will make it much quicker. I'm just doing it अंदाजे से, तो might not be very accurate, but it serves the purpose. Okay. Achha, let's draw this original function. Minus 5 over 4 is minus 1.25, right? It's, or you can just say slightly less than negative 1, slightly less than negative 1. So mark 1 point there to the left of negative 1 and then slightly below 0. So you'll have a point around here maybe. Look at this point. This is 1 point. This is where the graph is going to start from. What's the y-intercept of the graph? This is the y-intercept of the graph at the point 3. Right, the constant term. So the graph is going to look like this. This is what the graph looks like. You label this is f of x. ठीक है. What's the treat for the admins people? What more treat do you want? You're getting free past paper sessions every day. You do well inshallah. A levels में आएंगे तो if you get a good grade, we can talk about something more as well inshallah. अगर आप लाहौर से हैं तो you can have an actual treat as well. Okay. जब भी आप फंक्शन का ग्राफ बनाते हो और उसके इनवर्स का ग्राफ बनाते हो, you always need to draw this line as well. Y equals x line. It has to pass through the origin. It has to pass through the origin. And it should be passing through the points 1, 1, 2, 2, 3, 3, and so on, right? Now, my graph is not very, my labels are not very accurate, so I'm just going to do it roughly. It will look like this roughly. Okay. This is the line y equals x. You have to draw this line y equals x. ठीक है. You will make it dotted generally. So make it a dotted line like this. Label this as well. This is the line y equals x. Now remember, graph of a function and its inverse, they're always reflection of each other. They're always reflection of each other in the line y equals x. So you always have to draw this graph. Now, how do you draw the inverse function? Should we find the inverse function first? It's not required. It's not required. You can just reflect this graph. Now, how would you reflect the graph? You just interchange the points. So you know the y-intercept of this graph was at 3. So the x-intercept of the inverse graph, that is going to be at 3 on the right side. This is the x-intercept of the inverse graph. Achha. What about this point? The turning point, that is also going to flip. The coordinates are also going to flip in that case. So it is going to become minus 1 over 8 and minus 5 over 4. Right? So on the x-axis, it will be slightly to the left. On the y-axis, it will be slightly below 1, below negative 1. So that point may be somewhere around here. Okay? So you have this point here, and you have the x-intercept here. Now you just draw a curve like this. That looks like a reflection of that graph. So like a horizontal parabola. And that's what you would label as f inverse of x. And that's our final answer. This is what we were looking for. ठीक है. Makes sense to everyone? Does this make sense to everyone? Let's move on. These graph questions are very annoying because they are very time-taking. This was a 5-mark question, so it's still worth the effort. But sometimes they are not worth a lot of marks. Okay. ठीक है. Chale, let's look at the next one now. Now they're saying 5 LGA minus 4 LGB minus 3. Write this as a single base 10 algorithm or logarithm, not algorithm. How do we do that? How do we do that? LG means base 10, right? We have to write it as a single log. How can we do that? We can take 5 to the power, we can take 4 to the power. Let's do that first of all, because otherwise we cannot apply the division law, multiplication law, unless we have gotten rid of the numbers outside. So it becomes LG a raised to power 5 minus LG b raised to power 4. Okay? Now, what about this? What about this? How do we write this as a log term, negative 3? Remember, what is LG10? What is LG10? LG10 is equal to 1, right? LG10 is equal to 1 because log base 10 of 10, that is equal to 1. So what we can do is we can say, let's multiply 3 by LG10. LG10 is just 1, so it's not going to make any difference, right? 3 times 1, it's still 3. So it's still the same number. We're not changing anything. And now you could say Take 3 to the power, so it becomes LG 10 raised to power 3, which is 1000. Okay. Now write it as a single log term. How can we do that? This is minus, this is minus. We can use the division law, right? All the terms that have plus signs with them, they will come in the numerator. So this will come in the numerator. There's a plus sign with that. So a raised to power 5 in the numerator. The other terms have negative signs with them. They will go to the denominator. B raised to power 4 goes to the denominator. We've got b power 4 here. And 1000 as well. So we could say b power 4 into 1000. You can just leave it like this or write it as 1000 b raised to power 4, and that will be your final answer. Okay. Makes sense to everyone. All right. Chale, let's move on. Now they're saying solve this equation. Solve means you have to find the value for x in this. How do you find the value for x? Log of x plus 1 with base 5, log of 5 with base x plus 1. We've got different bases. We have different bases. Now, when we have different bases, we need to use change of base law to make the bases the same, right? Let's do that. Let's make the bases the same. We can say log of x plus 1 base 5. Can we make the base of this number, this log 5 as well somehow? We can use the change of base law like this. We could say, if we want to make the base 5, log of 5 base 5, which is 1, you can just write that as 1 as well, right? You can take reciprocal and flip the bases. That's how it generally works as well, right? So for example, if you have, let me write that down on the side. If you have log of a with base c, that's the same thing as log of a with base c, if you want to use change of base law like this, and divided by log of b with base c. But if we just want to switch these numbers, you can also just do 1 over log of b base a, because in the numerator, like in this case, you will always get 1 in this case if you want to just flip the two numbers. So you can just write 1 directly as well, and that will be okay. In the denominator, you have log of x plus 1 base 5. On the other side, there is 0. Okay. As I said, numerator can be written 1 directly as well. ठीक है. अच्छा. Now we can take LCM. We can multiply this here. We can take substitution as well. If you find this a bit complicated, you can use substitution. For example, you could substitute this whole thing with another letter. That might make things slightly easier to understand for you. You can do it directly as well. It's not that difficult. Multiply this on the other side. What does that become? That becomes log of x plus 1 base 5. So what I'm doing is I'm multiplying the whole equation by log of x plus 1 base 5. Okay? It's like taking LCM and then multiplying the denominator on the right side. We can do all of that in one single step. So square of this number minus this becomes 1. That equals 0. Okay, now 1 goes to the other side and we get log of x plus 1 base 5 whole squared. That is equal to 1. Now we have to take square root. When we take square root, we always have plus minus. Do not forget that. Okay? Do not forget plus minus. So you get log of x plus 1 base 5. That is equal to plus minus 1. Now, we need to get rid of the log now. Let's split it into two parts. Log of x plus 1 base 5, that is equal to 1, or log of x plus 1 base 5, that is equal to negative 1. Now, how do you get rid of this base 5? Get rid of the log? What we can do is we can say, let's take 5 to the other side, make it the base of that number 5, base of that number 1, in power form. So it becomes x plus 1 equal to 5 raised to power 1. It's equivalent to saying raise both sides to power 5, or in fact, have 5 raised to power something on both sides. It's equivalent to that. Now, the first equation, that gives us x equals 4. What about the second one? In this case as well, 5 goes to the other side. and it becomes 5 raised to power negative 1 on the other side, right? Now 1 over 5 minus 1, and that gives us x equals negative 4 over 5. Now these are two possible values of x that we're getting. Okay? Now, whenever in any problem you get multiple answers, you should always check, are those multiple answers possible? In some questions, they tell you in the question that you get multiple answers. For example, let me show you something. In one of the previous questions that we did here, we were getting multiple answers, minus and plus 4 over 5, but the question said possible values. That means we were supposed to get multiple answers, okay? So we did not need to check them. But in this question, they are just saying solve this equation. So it's not clear if we are only going to have one answer or multiple answers. So if you end up getting multiple answers, always check, are all of them possible or not. Okay. Now, how do we check them? X equals 4. Can you input x equals 4 here in the original equation and you will still get everything positive inside log? Yes, 4 does not cause any problems. You can input that, you will get positive results inside log. Okay, what about this? X equals negative 4 over 5. Input that in these logs. Does any of the two logs become undefined? It does not, right? It does not become undefined because minus 4 over 5 plus 1, that is positive. Here as well, minus 4 over 5 plus 1, that is positive. So we're not getting anything undefined. That means both answers are possible. Sometimes it can happen that one of the answers will make some log undefined. You'll have to ignore that answer. Okay. Okay, let's move on now. Question number 6. Okay, we'll get to question number 7 as well. It's all, we're almost there. Let's try this now. Solve this equation. It's a modulus equation. How do we solve modulus equations? How do you solve modulus equations? There are two methods for this, right? Either you square both sides, that is one possibility, or you can remove the modulus and put plus minus in place of that. I prefer the plus minus method. That I think is quicker. So remove the modulus, put plus minus in place of that. Plus minus 2x squared plus x minus 10, that is equal to 5. Now you get two equations from that. One equation is 2x squared plus x minus 10 equal to 5. And the other equation is minus 2x squared minus x plus 10 equal to 5. Now these are both quadratic equations. We need to solve these quadratics now. 2x squared plus x minus 15 equal to 0. Can we factorize this? 2 times negative 15 is negative 30. 6 and 5 would work, right? So we can say 2x squared plus 6x minus 5x minus 15 equal to 0. We get two factors from this, 2x into x plus 3 minus 5 into x plus 3. So we have 2x minus 5 into x plus 3, that is equal to 0. One possible value of x that we're getting from this is x equals 5 over 2. Another possible value of x that we're getting is x equals negative 3. These are two possible values of x that we're getting. Okay. Okay, what about the other equation now? If I take all terms to the right side, what does that give me? That gives me 2x squared plus x, and this will be negative 5 this time, right? 5 minus 10, that will be negative 5 equal to 0. Can we factorize this? 10, we cannot factorize this, right? Let me just check my working again. Minus 2x squared minus x plus 10 is equal to 5. And then 2x squared plus x minus 10. Yeah, so we cannot factorize this. So what do we do then? If we cannot factorize, we use quadratic formula. What's my opinion on the weather? It's good. I want to go out at this point, but I had promised that I'll be starting the classes at this time. But yeah, I really like weather like this. We're in Lahore, if that's what you're talking about. हमारी साइड में उससे ओले नहीं पड़े, तो जहाँ पे वो हुआ है तो वो थोड़ा सा डेंजरस हो जाता है लोगों की गाड़ियों के लिए. बट बारिश इज समथिंग आई रियली एंजॉय. अच्छा, फैक्टराइज तो नहीं कर सकते. So what do we do then? -1 plus minus square root of 1 squared minus 4 into 2 into minus 5 whole divided by 2 times 2. Achha, what do we get from this now? Remember, we are not allowed to use a calculator, so we'll just have to, do our calculation like this and give an exact answer at the end. 1 plus 40, right? That will be square root of 41 divided by 2. These are two other possible values of x that you're getting. You can leave it like this if you want. You can also write them separately, the plus 1 separately and minus 1 separately. And these are our final answers now. X equals these two values, or x equals 5 over 2, or x equals negative 3. Now, in this case as well, in modulus equations as well, we need to check if all the answers are really possible or not. We need to check if all the answers are really possible or not. Okay, I'm sorry, divided by 4. Yeah, sorry about that. We need to check that all the answers are possible, because sometimes in modulus equations, we can end up getting extra solutions. That is possible sometimes. Okay. So you can, now I would recommend that you do it at the very end in this case. Generally, the problem happens, in this case, that problem would not be there, but sometimes if you have x on the other side as well, that is when the problem happens. In this case, you won't have that problem. In this case, it's just a constant on the other side, so that's going to be fine. But when you have x plus minus something on the other side as well, in that case, it's important that you verify your answers as well. Okay, that's important in that case. Achha, let's move on. Let's move on to the next one. Question number 7. Okay, we got to that question that you were talking about. Let's try this. लाइट चलेगी या बारिश जैसी होती है, लाइट को कोई मसला हो जाता है. That's true. Okay, इसमें क्या है? Point A has coordinates -2, 4. B has coordinates this, and C has coordinates this. Find the gradients of the lines AB, AC, and BC. Okay, find the gradient of AB. See what that turns out to be. 10 minus 4 divided by 6 minus -2, that's 6 plus 2. That equals 6 over 8, which is 3 over 4, right? That's the first gradient. Let me just check my working again. 10 minus 4 divided by 6 plus 2. Okay. That's one gradient. Then AC, let's find that. AC, that is 2 minus 4 divided by 12 minus -2, that's 12 plus 2. And that becomes -2 over 14, which is -1 over 7. Okay. Then gradient of BC, what's that? That is, if I do this, 10 minus 2. And then divided by 6 minus 12. Okay, what does that give us? In the numerator, we've got 8. In the denominator, -6. So that's -4 over 3. Okay, so they made you find these gradients in the first part. Now they're saying, hence find the equation of the circle which passes through the points A, B, and C. Acha. Now in circle equation questions, it's always a good idea to make a rough sketch that helps you understand the situations better. In circle equation questions, always make a rough sketch. That'll make it easier to understand the problem. We are looking for the equation of the circle. Equation of the circle is of this form, right? X minus a whole squared plus y minus b whole squared equals r squared. Now, to write down the equation, we need two things. Number one, we need the center. Number two, we need the radius. So we need the center of the circle and the radius of the circle. Those are two things that we need for this. Now, we don't have any of them. But if we can find the center somehow, finding the radius is no problem then, because we have 3 points on the circumference. Finding the distance of the center from the circumference, that will give us the radius. Okay. So the main issue is just finding the center of the circle. Now, how do we do that? How do you find the center of the circle? Let's try to understand the situation. They made you find gradients in the first part. That's a hint as well, but let me just show you how they would look like on the graph. So -2, which one has the smallest x coordinate? A, right? So it will be on the extreme left, and its y coordinate is in the middle. So let's mark A somewhere here. This is point A, let's say. A has coordinates -2 and 4. This is 1 point on the circumference of the circle. 6, 10. So it will be slightly to the right and up. So maybe it is somewhere around here, maybe. This is point B that has coordinates 6 and 10. Achha, there's another point then, and that is point C, and that is 12 and 2. That will be on the extreme right. 12 and 2. Let's suppose that is around here. Okay, this is point C, let's say 12 and 2. Now, notice what they have made you do in the previous part. They made you find gradients. This is 3 over 4, and this is negative 4 over 3. One is 3 over 4, and the other is negative 4 over 3. They are negative reciprocals of each other. What that tells you is AB and BC, they are perpendicular to each other. AB and BC are perpendicular to each other. Okay, AB and BC are perpendicular. So what that means is we are going to have a right angle here. If I were to make lines here, this is a right angle. And does that remind you of something? When do you get a right angle on the circumference? When do you get a right angle on the circumference? Length equate कर सकते हैं? That's not going to help. Length तो equal होगी भी नहीं, as in how can we make that assumption? But we are getting a 90 degrees angle on the circumference of the circle. That should remind you of something. There's a circle property that we've got. The only chord that makes a 90 degrees on the circumference is the diameter, right? So what that means is if I were to join A and C, this is going to be the diameter of the circle. So AB is perpendicular to BC. That implies that AC is a diameter of the circle. Okay? Isn't this too tricky for 4 marks? It is, but that's something that gets repeated quite often. Since it has been added to your syllabus very recently, I would recommend that you attempt some, although you still have like at least a few questions to practice, but do more practice from some A-level papers as well. You'll find some good questions there. This is a property that keeps coming up again and again. You need to just keep that in mind. Whenever you have two chords in a circle that are making a 90 degrees with each other, one of them, and they have a common point like this, then you get a diameter from that. Okay. If you take center as point X and equate the length of AX and BX, let me tell you why that would not work. Let's call this center X. So how can we find the point X now? Since AC is a diameter, X is just the midpoint of AC now, right? So the midpoint of AC, that will be -2 plus 12 divided by 2 and 4 plus 2 divided by 2. And that gives us 5 and 3. This is the center of the circle. These are the coordinates of the center of the circle. ठीक है? Yes, so that's true. Then you see, you look at the pattern of the question as well. It's a circle equation question primarily, right? They just gave a 2 mark question in the beginning, but then you have a bigger question on circle. Why would they randomly make you find these gradients? They have some use in the next part, right? So think about what that use is. Are any gradients the same? They're not. So there are no parallel lines as such, but there are two gradients that are negative reciprocal of each other. So they're perpendicular. And that is something that is going to help you find the center of the circle. Now, once we've got the center of the circle, finding the radius is straightforward now. Find the distance of x from any of those points. I can say xc, for instance. That may be one way to find the radius. Or find AC, divide that by 2. Any of them would work. Let's just find xc directly. What would that be? Square root of 12 minus 5. This is 5 and 3. 12 minus 5 whole squared plus 2 minus 3 whole squared. Now, the diagram is not very accurate, and that's okay. It doesn't matter. We just made that to think about how the situation would look like. This is 3, this is 2. So center was supposed to be slightly above. That's okay. Yeah, so this had a bigger y coordinate, so I should have drawn C below here somewhere. But it's okay. We get the correct result from that. It was just for our own understanding. The examiner is not going to check this. The examiner is not going to check this, but I should have marked the point C. I should have marked the point C below point A, right? Because its y coordinate is smaller. But anyway, I've done that now, so it doesn't matter. 7 squared, that is 49. 49 plus 1, that's square root of 50. Okay, that's the radius of the square of the circle that we're getting. We can write down the equation now. X minus a whole squared, that means x minus, this is the center now. This is the center, this is the radius. X minus 5 whole squared plus y minus 3 whole squared equals square root of 50 squared, and that will be 50. This is the equation of the circle that we were looking for. Okay, that's what we wanted. So there is a suggestion there. You're saying, what if we say, write down the coordinates of x as a, b maybe, and then you find the distance ax, equate that to distance xc. Now that's not going to help because this is going to be true for every single point on the circumference. For every single point on the circumference, you have the same distance from the center. You need another equation as well. What other equation would you use along with this? You'll have to use the gradient somehow. That is going to be necessary, right? Now, if you use the gradients, figuring out that AXC is a straight line, that is still going to be important. Because if you can't figure that out, then you would not be able to recognize that AX and XC, they are in the same direction. If you are able to recognize that, then you could use the gradient formulas that gradient of AX is also equal to gradient of XC, and then solve them simultaneously to find that point X. But that will be much more working, not very efficient. If you're able to figure out that that's the diameter, that's important, then this is the center of the circle. Now, there's a general way, there is a general way of doing such problems in case you cannot figure out something as a diameter. There's a general slightly longer method. Let me just show that to you quickly. How to deal with problems where they give you 3 points on the circumference. That's what they've done here, right? They've given you 3 points on the circumference and they want you to write down the equation of the circle. Now, in this case, we figured out a diameter, so it became slightly quicker. But if you can't do that, then the general method that works for such problems is that, yeah, if we have 3 points on the circumference, for example, if you know this point A, this point B, and this point C, you have 3 points on the circumference. That's all that you know. And you want to write down the equation of the circle. You have this property. It comes from circle properties. Remember that property where you say midpoint, if you were to draw a line from the center of the circle to the midpoint of any chord, it always makes a 90 degrees, right? It comes from that property, and that is perpendicular bisector of every chord in a circle. Perpendicular bisector of every single chord in a circle passes through the center of the circle. For any chord in a circle, if you were to draw a perpendicular bisector, it would pass through the center. So how can you find the center then given 3 points on the circumference? So for example, let me just erase these highlights. if you have 3 points, A, B, and C, join any two sets of points. So what I've done is I've joined A and B, and I've joined B and C. Now that gives us two chords. The perpendicular bisectors of those chords, they are going to pass through the center. So what you do is you find the perpendicular bisector of AB. Find this equation. Find the equation of that. Find the equation of the perpendicular bisector of BC. That's the second thing that you do. The center of the circle lies on their point of intersection. How can you find the point of intersection of any two functions? You solve them simultaneously, and that is going to give you that center's coordinates. It's longer, but that's a general way of doing such problems. Okay. In this question, however, they told you in a way that the diameter is going to be AC. So it was much more efficient to just use that. Okay. Make sense to everyone? Does that make sense to everyone? Okay, let's move on to the next one. Question number 8. Okay, what about this now? Question number 8. Let's try this. Achha. Now they're saying on these axes, sketch the graph of y equals 5 ln of 4x plus 3. State the intercepts with the axes, state the equation of any asymptote. Where is the asymptote of a log function? Where is the asymptote of a log function? You need to remember this. For a log function, the asymptote is when the part inside the log that is equal to 0. That's where you have the asymptote. 4x plus 3 equal to 0. So the asymptote that you have for this is x equals negative 3 over 4. It's a vertical asymptote. Okay, minus 3 over 4. You have an asymptote at that point. You draw that. You can say this is negative 3 over 4 on the left side somewhere. You will make a vertical line here, make it dotted, because that's not the actual graph. That's the line through which the graph cannot pass. The graph is going to become almost parallel when it comes close to this point. Okay. Let's label that as well. This is x equals minus 3 over 4. Achha, now that's the asymptote. Now find the x-intercept, find the y-intercept. Find the x-intercept and find the y-intercept. How do you find the x-intercept? Remember the shape of the graph, the shape of the log graph. Shape of the log graph. There are 4 possible shapes, right? So this is the standard log graph, but you could have transformations for this, right? It could become this, it could become this, it could also become this, right? These are 4 possible shapes that you could get with a vertical asymptote. Yeah, you can. It's the inverse of exponential function. Yeah. So log function is inverse of e raised to power x. Ln x and e power x, they are inverse of each other. Yes. Achha. What were we doing? Yeah, x-intercept and y-intercept. Let's find those. If I put x equal to 0, what do I get from that? Y equals 5 ln 3. So that's the vertical intercept that we've got. Let's mark this point somewhere here. This is 5 ln 3. Now, how do we know it's a positive number, by the way? How do we know it's a positive number? Log of something, it could be negative as well. How are we sure that this is positive? Ln x is positive if x is greater than 1, and it's negative if x is less than 1. Not just ln, any log, log with any base. it's going to give us a positive result if this number is positive, and negative if the number inside is less than 1. That means it's between 0 and 1. So numbers between 0 and 1, they give us a negative log. This is 3, so it is going to be a positive value. So on the graph, we're going to plot this point above the x-axis. Okay, now what about the y-intercept? You put y equal to 0. When you put y equal to 0, what do we get from that? ln of 4x plus 3, that is equal to 0. ln goes to the other side, becomes the base of 0. E goes to the other side, becomes the base of 0 in power form. So e power 0. E power 0 is 1. So we have 4x equal to 1 minus 3, which is minus 2. So x equals negative 0.5 or negative 1 over 2. So you can mark that somewhere here maybe. This is negative 1 over 2. Now you can draw that graph. This is log function. It's not being multiplied by negative either outside or inside. It has to pass through these points. The standard log shape is this, right? If there's no transformation. So it will be like this. It is going to pass through these points, become almost vertical here. And on the other side, it will become kind of like this. That's the graph of this log function. Is that okay? In A levels, they give you this for 2 marks instead of 4. And they give you an additional graph to sketch along with this. So 2 graphs and 2 marks in total for that. So essentially it becomes 1 mark in A levels, just sketching this. Okay, that's your question number 8. If you know how to do it, this is pretty straightforward. You're welcome. दुआओं में याद रखें आप जो भी आपका नाम है. ये वैसे नाम आप लोगों के किस तरह से आते हैं? ये एनोनिमाइज करके होते हैं या एक्चुअल आप लोगों के अकाउंट नेम्स ही होता है? आई एम एक्चुअली नॉट फेमिलियर विद दिस. जो आप लोगों के अजीब अजीब नाम आ रहे होते हैं यहाँ पे. डू यू गेट एन ऑप्शन टू एनोनिमाइज योर नेम या फिर ये बस आपके अकाउंट का नाम ही है स्टैंडर्ड? Can I explain that positive thing again? Remember ln x graph? ln x graph, what does that look like? This is the standard shape of the ln x graph, okay? This is the shape of the ln x graph. Now, you could get transformations of that. You could get transformations of that. You could get something like this, or this, or this, depending on if you have something multiple. For example, if you have ln of minus x, that's a horizontal reflection. That means reflection in y-axis. It will become this. If you have minus ln x, it gets reflected in the y and in the x-axis, it becomes this. If it's minus ln of minus x, it becomes this. However, there's an easier way of doing this as well. Once you have taken those points, I'll just leave it on the side here. Once you've taken these points, so you have this point, you have this point, you have these 2 points, right? And you also know that this is the vertical asymptote. This is the vertical asymptote. There are only 2 possibilities. If this is the asymptote, either the graph is going to go towards positive infinity here. That's clearly not happening because of the order of these points, right? It has to go in the downward direction. So there's only one possible graph that you could get from this. You don't even have to think of any transformations. As long as you have these 2 points and the asymptote right, the only possible shape that you would get could be this. So just remember, it's going to be one of these shapes. One of these 4 possible shapes. And then just take some points and you will understand which one of these shapes it is going to be. ठीक है. मैं सर 7 जैसा क्यों बोलता हूँ? I'm not sure. A lot of people have said that for some reason. I have no idea. I think is much more eloquent, mashallah. Maybe the voice is similar. I don't know if it is, to be honest. Uh, How do we figure out if an ln function and its inverse will intersect or not? Uh, so if two functions are inverse of each other, there's a general rule. If two functions are inverse of each other, if they intersect, they always intersect on this line, y equals x. So if any of those graphs is intersecting, if any of those graphs is intersecting, uh, or both, if the graphs are intersecting with each other, then that means both the graphs are intersecting with y equals x as well. So you can just check whether they intersect with y equals x graph or not. So if they intersect with y equals x, then they intersect with the inverse function as well, if that was your question. Okay. So if a function intersects with y equals x, then it also intersects with the inverse graph because that is where they can become equal. Okay, let's look at question number 9. Now they're saying a curve has this equation. A curve has this equation. A curve f of x is such that the second derivative is this. The curve has gradient 2 over 3 at the point 2, 2. Okay, find the coordinates of the stationary point on the curve. That's an 11 mark question. Wow. Okay, so let's start. परेशान नहीं होना इसको देख के. It doesn't look very difficult. It's just that it's 11 marks only because you have to do some thinking on this yourself. But when you actually start it, it probably is not going to be very difficult. Okay, let's start. Let's begin with this. You have the second derivative. Achha. Now, how do you find stationary point for any function? How do you find stationary point for any function? You put the first derivative equal to 0. That's how you find the stationary point for any function. Put the first derivative equal to 0. So you integrate and find the first derivative from this. This is the second derivative, right? So to get to the first derivative from this, you integrate the functions f prime of x, yeah, f dash of x. How do you integrate this? The expression inside is linear, so you can apply the power rule on this. 2x plus 5, add 1 to the power, minus 3 over 2 plus 1, that becomes minus 1 over 2. Divide by that new power, and also divide by the derivative of this, which is 2. But remember, whenever you integrate something, you always have a plus c. Okay, you always have a plus c, so you have a plus c here as well. Now in the denominator, 2 and 2 get cancelled. What are we left with? We have a negative sign. Do not forget that. This is negative power, so I can write like this: minus 1 over 2x plus 5 whole raised to power 1 over 2 and plus c outside. Okay. Now this is the derivative that we're getting. All right. Now this is what we're given. We are given that the gradient is 2 over 3 at some point. The point is 2, 2. So at some point, we know the value for x is 2, the value for y is 2, and at that particular point, f dash of x, that means the derivative, is equal to 2 over 3. So can we use any of that information to find the value for c now? We can say in this equation, since we have x, let's put that value, put x equal to 2, and put the derivative equal to 2 over 3, because when x is equal to 2, we know that this value is 2 over 3. And that will give us the value for C. Let's figure this out. 2 over 3, that equals minus 1 divided by 2 into 2 plus 5 whole raised to power 1 over 2 plus C. ठीक है. Achha, now, what do we get in the denominator? This is 4 plus 5, which is 9. 9 raised to power 1 over 2, that will become 3. So we have 2 over 3 equal to minus 1 over 3 plus C. This goes to the other side. 2 over 3 plus 1 over 3, that's 1. So we have the value for C as 1. And we know now that the derivative f prime of x, f dash of x, that can be written as negative 1 over 2x plus 5 whole raised to power 1 over 2 plus C plus 1. Okay, we found the derivative now. We found the first derivative. Acha. Now, we are looking for the coordinates of the stationary point. Now, to find the coordinates of the stationary point, what we have to do is we have to put this derivative equal to 0, solve that equation, and that is going to give us the x coordinate of the turning point. To find the y coordinate after that, we also need the original curve. So we would have to integrate this again. You can either do that right now, or you can do it at the end after you found the x coordinate of the turning point. That's your choice. I'll do it at the end. Let's find the x coordinate of the turning point. First of all, what I'll do for that is I'll say, let's input the derivative equal to 0. Why are we doing this? To find the stationary point. Okay. Now, when we put this equal to 0, that gives us 0 equal to negative 1 over 2x plus 5 whole raised to power 1 over 2 equals plus 1, sorry. Take it to the other side, and that becomes 1 over 2x plus 5 whole raised to power 1 over 2. That equals 1. 1 equals 2x plus 5 whole raised to power 1 over 2. Square both sides because the power is 1 over 2, right? To get rid of the power 1 over 2, we have to square both sides. So that gives us 1 equals 2x plus 5. 5 goes to the other side when you get minus 4 equal to 2x, and the value of x turns out to be negative 2. Okay, so we have the x coordinate of the turning point now. Relative velocity is not part of our syllabus, yes. Relative velocity is not part of our syllabus. It is not part of your syllabus, yes. ठीक है, अच्छा. Now, once we've got the x coordinate, find the y coordinate now. How do we do that? We have to integrate that function again, f of x. Let's integrate this again. Achha, what I'll do is I'll write down the derivative in the power form. So it's minus 2x plus 5 whole raised to power negative 1 over 2 plus 1. Okay, that's the derivative. Let's integrate again. Minus into 2x plus 5 whole raised to power minus 1 over 2 plus 1, that becomes 1 over 2. Divide by that new power, also divide by the derivative of 2x plus 5, which is 2. Plus 1, do not forget the plus 1. What's the integration of 1? Integration of 1 is x, so we also have this x there. Is that it? Do we need to do anything else after this? Do we need to do anything else after this? Remember, whenever we integrate, we always have a plus c. So in this case as well, we have integrated again. We have another c now. We have another c now. Now we need to find the value of this c as well. That's why it was 11 marks. That's a lot of working. Okay, now it becomes minus 2x plus 5 whole raised to power 1 over 2 plus x plus c. That is the function that we're getting. Let's input that point now. We were given that x is equal to 2 and y is equal to 2. We have this point given. Input that point, and that gives us 2 equal to minus into 2 plus 5 whole raised to power 1 over 2 plus 2 plus c. Achha, what do we get now? 2 equals minus 9 raised to power 1 over 2, that becomes minus 3 plus 2 plus c, and the value of c turns out to be 3 from this. And now we've got that function as well. We've got that final function. F of x equals minus into 2x plus 5 whole raised to power 1 over 2 plus x plus 3. That's the equation of that original curve. We found the x coordinate of the turning point earlier. Let's find the corresponding y coordinate for this as well. So we put x equals negative 2 in this to get the corresponding y coordinate. So f of minus 2, that gives us minus into 2 into minus 2 plus 5 whole raised to power 1 over 2 minus 2 plus 3. Simplify this. That gives us minus 4 plus 5, which is 1. So that's minus 1 minus 2 plus 3. And that turns out to be 0. So what's the turning point then? The turning point that we were looking for, the stationary point. Its x coordinate was negative 2, the y coordinate is 0. And that's our final answer. This is the stationary point that we wanted to find out. ठीक है? Okay, let's move on. Let's move on to the next one now. So now they're saying determine the nature of the stationary point. You have the second derivative. They gave us that in the question. Just put x equals negative 2 in that and see what that gives you. Okay, minus, no, it was plus 2x plus 5 whole raised to the power negative 3 over 2. 2x plus 5 whole raised to power negative 3 over 2. This is one place where you end up doing a lot of careless errors. You have to be careful when you are copying one thing from one page to another. Let's input that value of x. X is negative 2. So 2 into minus 2 plus 5 raised to power negative 3 over 2. 1 raised to power anything is 1. So we have 1. 1 is a positive number. 1 is a positive number. What does that mean? If the second derivative is positive, if the second derivative is positive, you have a minimum point, right? This is a minimum point. Makes sense, right? Let me look at the stream again. Is it working fine? थोड़ा समझना रहा मैं दूसरी स्क्रीन पे. Yeah, okay. All right, let's look at the next one. Question number 10 from this paper. Show that this integral is equal to k pi, where k is an integer to be found. Okay. How do we do this integration? It looks pretty complicated, right? Sin theta plus cos theta whole squared. Okay. Achha, now first of all, can we apply the power rule on this? Can I apply the power rule on this? Add 1 to the power, divide by the new power, divide by the derivative of this thing. Is that going to work? Can I apply the power rule in this thing and the power rule in this thing? That is not going to work, right? Because the power rule requires whatever is inside the bracket, it has to be linear. It has to be linear. Okay, it has to be linear. So power rule does not work. So we have to simplify this. We have to simplify this. Let's see what happens if we simplify. Sin theta plus cos theta whole squared, that's a plus b whole squared. That will be sin square theta plus cos square theta plus 2 sin theta cos theta. Okay, again, we've got a minus b whole squared. What does that become? Sin square theta plus cos square theta minus 2 sin theta cos theta. Now you see something interesting happens here, that these two terms get cancelled. Now it looked pretty complicated, right? It looked so complicated just by looking at that expression, but you just expand that and now you see what's happening. 2 sin theta cos theta minus 2 sin theta cos theta, they get eliminated. What are we left with? What are we left with? Sine square theta plus cos square theta. Sine square theta plus cos square theta. That gives us 1 plus 1 d theta. And that is just 2d theta. So that complicated looking integral just simplifies to this. Now, what's the integration of 2 with respect to theta? It will be 2 theta. Input those limits. Limits are from pi over 2 to 3 pi over 2. Input the limits from pi over 2 to 3 pi over 2. If I input 3 pi over 2, that gives me 2 into 3 pi over 2 minus 2 into pi over 2. 2 and 2 get cancelled. 2 and 2 get cancelled here as well. 3 pi minus pi, that gives me 2 pi. They said it simplifies to k pi. If you compare with that, that gives us k equal to 2. Okay. Unknown gamers, I really don't know how to respond to messages like that. But I appreciate it. Spread the word and make dua for me. Okay, chale. Let's look at the next one. Question number 11. Question number 11. I hope you do well in your exams, inshallah. ठीक है, चले. Solve this equation. Solve this equation. Solving the equation means we need to find the value of n from this. We need to find the value of n from this. How do you find the value for n? N plus 1 C5, n plus 2 C7. Now remember the formula for this? NCR. What is that equal to? N factorial divided by n minus r whole factorial into r factorial. Right? That's what this formula is. Let's input values. N plus 1 C5. What is this going to become? In the numerator, we have n factorial. So this is n plus 1. It will become n plus 1 whole factorial divided by n minus r. That means n plus 1 minus 5. That becomes n minus 4 whole factorial. ठीक है, n minus 4 whole factorial. And then what about this? R factorial? We also have 5 factorial in the denominator. Okay, that's what you get on the left side. Now, what about the right side? N plus 2C7. N plus 2C7. Do the same thing here. N factorial, that is going to be n plus 2 whole factorial divided by n minus r. That becomes n plus 2 minus 7. Be careful. You do not want to make any silly mistakes here. N plus 2 minus 7, that becomes n minus 5. So n minus 5 whole factorial into 7 factorial. This is what it simplifies to. Okay, this is what it simplifies to. Now you need to get rid of those factorials somehow and make n the subject. Okay. Now, how can we do that? N minus 4. This is n plus 1 whole factorial. This is n plus 2 whole factorial in the numerator. Now, can we simplify them a bit so they get cancelled? N plus 2 whole factorial is a bigger number. So what we can do is we can keep n plus 1 whole factorial as it is. On the right side, what we can do is we can write n plus 2 factorial as n plus 2 into n plus 1 factorial. Right? It's like saying if you have 8 factorial, that's the same thing as saying 8 into 7 factorial. That's exactly what I've done here. This is a bigger number. So its factorial means n plus 2. into n plus 1 into n minus 1 into n minus 2. Now all of these, I could say they are n plus 1 whole factorial. So it can be simplified to n plus 2 into n plus 1 whole factorial. Okay. Now this thing and this thing, they get cancelled. Do the same thing in the denominator as well. Do the same thing in the denominator as well. Which one of these is bigger? N minus 4 or n minus 5? Which is the bigger number? N minus 4 is the bigger number, right? N minus 4 is the bigger number. So let's break that in this case. Let's break n minus 4. So n minus 4 can be written as n minus 4 into n minus 5 into n minus 6 into n minus 7 into n minus 8 and so on. That's the same thing as n minus 5 whole factorial. And we have 5 factorial as it is. On the right side in the denominator, we already have n minus 5 whole factorial, and then we have 7 factorial. Let's break it down as well. 7 factorial as well, since this is 5 factorial, this is 7, we're not allowed calculator. Let's simplify this a bit as well. I could write 7 factorial as 7 into 6 into 5 into 4 into 3 into 2 into 1. That becomes 5 factorial. Okay, that's a bit tricky, but it's something that you need to be able to do. Just make sure you're not making any careless mistakes here. Now, let's do cancellation. N minus 5 whole factorial. N minus 5 whole factorial, they also get cancelled. 5 factorial and 5 factorial, they also get cancelled. What are we left with? In fact, here as well, n minus 4 and n minus 4, they also get cancelled. What are we left with? On the left side, everything is eliminated. So we've got 1 on the left side. On the right, we have n plus 2 divided by 7 times 6, which is 42, right? Goes to the other side, 42 equals n plus 2, and the value of n turns out to be 40. That is what we were looking for. N equals 40. ठीक है. Any problems with this? I will be uploading more content. So what I'm doing is we're solving yearly past paper sessions in the next 8 to 10 days, inshallah. I'm starting with November. I've started with November papers. Tomorrow, most likely, I'll be doing March 26. Tomorrow, most likely, I'll be doing March 26. And then on Friday, on Saturday, inshallah, I'll be doing another November paper. And then on Sunday, the day before the exam, I'll be doing difficult questions from June and March 25. Okay. So 3 papers or 4 papers from June and March. We will do all the difficult questions from that. And then once you're done with the paper 1, then we'll do the same thing for the calculator paper as well, inshallah. Apart from this, you have a lot of revision content available already. Just search for paper 1 revision videos on my channel for A-level maths paper 1. A-level maths paper 1, because there's a lot of overlap between that and your AdMath syllabus. What I'll do is I'll actually make a separate playlist for AdMaths as well for the topics that are relevant for you guys, and you'll find them very helpful. Go through those revision videos. When is the Eid, by the way? Your exam is on 26, right? I think Eid is expected on the same day or the day after that. Yeah, so that's unfortunate for you guys. Left side पे 1 कैसे आया? Everything got cancelled, right? So if I have, for example, 5 over 5 and they cancel out like this, what am I left with? 1, right? 1 ही बचता है ना? Yeah, it's probably the day after your exam. Okay, chale. Let's look at the next one. We have 2 questions left, I think, 12 and 13. Okay, we're almost done. Let's do this one. Acha, by the way, if anyone has the March 26 paper, a good, as an easily readable version of that, please share that with me. It's not available officially yet. I'll have to search for it on Reddit. If somebody can do that and share that in the group, that will be helpful. Okay, let's do this now. A curve has this equation. A curve has this equation for x less than 2. Find the value of dy over dx when x is equal to 0. So let me actually leave this in the comment here as well. Yep. If you're in the WhatsApp group, please share that in the WhatsApp group. Their marking schemes are not available yet, right? They were not available for A-level papers as well. But if you have a good copy of the paper, please do share that. Okay. Achha, let's do this. Find the value of dy over dx when x is equal to 0. How do you differentiate it? It's a quotient, it's a fraction. We can use the quotient rule for this, right? What's the quotient rule? vu dash minus uv dash divided by v squared. Uzair, please fill out the form. Yeah, so leave a message in the message on that on the number that's written there as well. You'll be added to the group. Okay, all right. Acha, dy over dx is equal to, you'll be added inshallah. This is the quotient rule, right? Let's apply that. Dy over dx. V as it is, that means the denominator as it is, into derivative of e power x squared. What's the derivative of e power x squared? E power something, e power anything, that remains e power that thing, right? E power x squared as it is, multiplied by the derivative of x squared, which is 2x. Okay. Minus uv dash, that means u as it is, e raised to power x squared as it is, into v dash derivative of x minus 2, that is 1. What about the denominator? Square of x minus 2. Now that's the derivative. You don't need to simplify this, just input the value for x directly. And that will be quicker. Put x equal to 0. Okay. Find the value of the derivative that you get from this. You get 0 minus 2 into e raised to power 0 squared is just 0 into 2 times 0. That will just, that's gonna, that whole thing is going to become 0 because of that, right? Minus e power 0 whole divided by 0 minus 2 whole squared. Achha. Now let's simplify this. In the numerator, we've got 0. This whole thing is 0, right? Minus 1. So minus 1 divided by minus 2 whole squared, that's 4. That's minus 1 over 4. These are easy 4 marks. That's all that you have to do in this. Okay. Achha. Let's look at the next one now. When x is equal to 0, y is increasing at the rate of 0.5 units per second. Find the corresponding rate of change of x. Is that 1 over 4? There's a negative in the numerator, right? And the denominator is positive. There's a square on the denominator. Yeah, negative 1 over 4. Achha. When x is 0, the y coordinate is increasing at this rate. So what we are given is that dy over dt, that is 0.5. What we want to do is, we want to find the corresponding rate of change of x. So dx over dt, that is what we want to find out. Now, how do you find dx over dt? We have to use chain rule for that, right? Dx over dt, that equals product of two fractions. What are those fractions going to be? In the first fraction, we're going to have the numerator from this, that's dx. In the second fraction, we're going to have the denominator from this, that's dt. And in the remaining places, we just have whatever the third variable is. What's the third variable in this case? That's y. So we've got y here and we've got y here. Right? That's what the chain rule says. Now, dy over dt, we already know that. What about dx over dy? At x equal to 0. They made you find the derivative at that point in the first part already. So we know at that particular point when x is equal to 0, dy over dx has this value. We already have that. So when x is equal to 0, the value for dy over dx is negative 1 over 4. Now what about dx over dy? That will be negative reciprocal of this. So it becomes, sorry, not negative, reciprocal of this. That's minus 4 into 0.5, minus 4 into 0.5, that's half of that. That means minus 2. That's dx over dt that we were looking for. ठीक है. Okay, let's look at the last one now. Question number 13. Yeah, that is the last one. For x between -1 and +1, it's given that x is equal to this and y is equal to this. Find y in terms of x. Okay, why are we given that domain? X is between -1 and 1. Okay, so what we have to do is we have to make y the subject, right? We have to make y the subject. Let's do that. Let's make y the subject and see how we can do that. X equals 2 minus 3 sine theta. If I make sine theta the subject here, we want to get rid of theta, right? We need to get rid of theta from these equations. If I make sine theta the subject, that gives me 2 minus x divided by 3. Okay, sine theta equals this. Now, if I take inverse of this, that's going to make things complicated. Let's just leave it as it is for now. In the other equation, we have 3 cot squared theta. Let's simplify that a little. Let's simplify 3 cot squared theta. How can we simplify this? Cot is cos over sine, right? Cot is cos over sine. Is that amount of working sufficient for 4 marks? Yes, we have shown full working. This is full working. There's no step that we have skipped. So you'll get mark for writing this and then this. These are 2 marks. Acha. You were saying the previous part, acha, this part? Yes, this is enough. So you'll get at least 2 marks for this, at least 2 marks for this. And then you'll have 1 mark for inputting that value and then 1 mark for the final answer. Yes. Okay. 2 marks for this, 1 for inputting the value for x, and then 1 for the final answer. Acha. Now in this, cot can be written as cos over sine, and then we can input this. Okay, so that's actually not that complicated. Cot square we can write as cos square theta over sine square theta, right? Tan is sine over cos, so cot is cos over sine, so we can write it like this. Now we have sine theta given here. So if sine theta is this, we have cos square theta over sine square theta. In place of sine square theta, we can just input that value, right? However, in place of cos square theta, let's actually write it like this. Cos square theta can be written as 1 minus sine square theta divided by sine square theta. And now we can just input that expression here, and that will give us y in terms of x 3 times 1 minus, that's going to be a fraction inside a fraction. Let's make it slightly bigger. Okay, 1 minus 2 minus x divided by 3 whole squared, whole divided by 2 minus x over 3 whole squared. Let me just check this again. Sine theta is 2 minus x over 3, that's fine. 3 into cos square theta over sine square theta, 1 minus sine square theta, 1 minus 2 minus x over 3 whole squared. Yeah, it looks okay. Let's simplify this now. Let's simplify this. In the numerator, let's take LCM. In the numerator, let's take LCM. What does that give us? If we take LCM in the numerator, remember this is a square. Do not forget the square on top. I would get, if I take LCM, 3, so we have 3 outside as it is. 3 minus 2 minus x whole squared divided by 9. Okay, not 3, it's going to be 9. 9 minus this. Similarly, in the denominator, we have 2 minus x whole squared divided by 9. Now 9 and 9, they get cancelled, and that gives us the final result that we wanted. We can multiply 3 inside as well, and that is going to become 27 minus 3 into 2 minus x whole squared divided by 2 minus x whole squared. That's it. You don't have to simplify this any further. You can just leave it like this, and that's our final answer. This is what we were looking for. What if we replace cot with cosecant? Cot with cosecant. Okay, so you're saying let's use this identity. 1 plus cot square theta is cosecant square theta. So we could write this as 3 cosecant square theta minus 3, or let's cosecant square theta minus 1. Yeah, that's actually very smart as well. So yeah, in that case, you'll not have to use this 1 minus sine square theta. So yeah, you can do that. Then cosecant you can write as 1 over sine. You can write that as 1 over sine. 3 into 1 over sine square theta minus 1. Input reciprocal of this then. That will be 3 into 3 squared divided by 2 minus x whole squared minus 1. And that gives you 9 over 2 minus x whole squared. No, 27 over 2 minus x whole squared minus 3. And that's the same thing as this, but slightly more efficient. Slightly more efficient. Yes, you could do that. That will avoid that fraction inside fraction. Yeah, that's a good idea as well. So that will be an alternative. That will be an alternative. Because cosecant is reciprocal of sine, right? In the other equation, we had sine already. So that makes it, maybe one step quicker. And we avoid this fraction inside fraction. A lot of people end up doing careless mistakes in this case. Okay. Okay, I hope that was helpful. This is it for today. In the next class, I want to do the March 26 paper, inshallah. March 26, I think somebody has shared them with me. Let's do that tomorrow. March 26 paper, inshallah. Okay, so almost every day and during the next 8 to 10 days, inshallah, we will be doing one past paper or difficult questions from multiple past papers the day before each exam. If you want to be part of the group, you can join using the link in the description. It's also a pinned comment in the chat. You can join using that. So I'll be posting there in the group what time we're going to be starting each class and what papers we're going to be doing in every single class. So you can attempt those papers before we start. And then, you look at the solution after that. Otherwise, it's not helpful if you're looking at the paper the first time when I'm doing it. Just by watching everything, watching me do everything, that's not going to be helpful. It's okay for maths because maths is like fairly straightforward. But for ad maths, you need to do a lot of practice with your own hands. That's important. ठीक है. Okay, all right. So make sure to share with your friends as well who are taking ad maths so more people can benefit. I'll see you in the next class, inshallah. Edexcel students, Edexcel का syllabus थोड़ा सा different है, but if you just want to join just for learning, you're most welcome to do that. Yeah, the paper pattern is slightly different, but still the content should be helpful. Okay. All right. So those of you who have filled the form, you will be added. It takes a bit of time, but you will be added before the next session. Most likely tonight, you will be added, but otherwise in the morning. Tomorrow, we are doing March 26th, that exact time that we will do it. I will let you know in the group, inshallah. Okay. See you in the next session. Allah Hafiz.